method, so this is equation that we have seen that like fn, fn means that function that we have written, right? Fn means, I will tell you, n power k log p n, right? It's like to short that. Okay. So this is the condition: a is greater than 1, b is greater than 1. Right? So this is like professor's first example. Can you solve this? If you find easy for this, okay, just solve it first, because it's like what? One line? Close? No, it's like one switch for the whole line. It's like a equal to 4, b equal to 2, n equal to 1. So there is no log, so p equal to 0. Just you have to apply the formula. It's like a different method. Just I have given you my method, and this is like a different method. It's easy. This one? Same?
Yeah.
I don't know because I have not seen this. This one? This we had solved it? 14? If not solved, just solve it because we solve it.
Yeah.
This one we don't solve it. Can you solve it? This is n cubed. If anyone has any doubt, I can come to him or her to solve it.
So another question I have is, these are showing big O or big omega, and the notes we were going through said theta, right?
Yes. I have given it here.
Theta, right? So are these different then?
No, these are same.
Same.
Yeah. Just if you apply this formula, you will get the same.
And you also need to know about the omega though. That looks different, right? So
Yeah, but this method is different.
Yeah.
Answer is the same.
so we always want the answer in theta, right?
Yeah. Like this method is like Professor Victor. That method I had learned from my professor. So I'm giving you, because this method is easy. Just you have to apply the formula. Right? So this question we had solved it. No, we don't solve it because it's n square. We have n, right? So can you solve it so that it's easy for you in your exam? Like a is 4, b is 2, k is 2, p is 1. So you can put the formula into like it's equal, like second condition, right? Because a equal to pk is equal. So p. So then you have to see with the p.
So even though it's a different log base, that usually is the same. You don't have to convert that to base 2.
This one?
That's log e, right? Log base e. So
there is natural log n
Yeah.
that we write.
Oh,
ln
that is
of
like
this.
this, sorry.
Yeah. So this is like, see this. This is the master theorem. This is a different method. It will go at that output only. This is a different method that will go at that output. Okay. So we will go through the recursion. We will go through the recursion tree method. So this is like t of n equal to tn upon 4 plus tn upon 2 plus n square. N square is a constant work that is divided into like two things, t of n by 4 plus t of n by 2. When we do this constant work, so the constant work is divided into like two, we can say occurrence or we can say instance. Okay. So t of n, so total work done is n square, so we will write n square, right? And then we will split the two occurrence t of n by 4 and t of n by 2. Okay? Like professor can ask you in an exam, like by giving this equation, like find out me the recursion tree for this. Okay? The equation will not be same, okay? Equation will be different. So this will go into like, this 4 will be squared, okay, it's like an n square, so it will be square, so n upon like then the two instance n upon 16, and then n upon 8, because n upon 8 is why? Because first is n upon 4, so we will double it, n upon 16. Second is like n upon 8. So this one is n upon 8 and this one is n upon 4. So this will go to the like theta of 1, means the work done should be 1. So if we will add this, n square is making the whole n square, and the second level we add this 5 upon 16 n square. So we will like adding the level, right? So then the next level we will add it, it's 25 upon 256 n square. So we will now just add this to find out the time complexity of this, right? So we will add this, so n square should be common, and 1 upon 516 upon square, so it's a geometric progression. You can find this like by geometric progression, but it's no use, right? Because constant doesn't matter for the time complexity. So it will take a bigger, right? N square is bigger, right? From this. So we don't have to calculate, so you can write directly theta of n square is a time complexity, because we are finding the upper bound of that. So n square is the upper bound. Got it? Yeah? Good? So we can find the time complexity by the recursion tree also and by the master theorem also. Okay? Because master theorem is having some loopholes where it can't, because master theorem is having an equation, right? If that is not an equation, we can't solve by the master theorem.
How did we find
5 or 16,
How did you define?
you have to add this n upon 4 whole square plus n upon 2 whole square, and then add it. Then it becomes 5 upon 16 n square. Yeah. Oh, yeah, I'll give you one more example. You want one more example for this equation? This. So this is our constant work, okay, and this we can say this constant amount of work. If we do some work constant C amount, we could break into two instances, right? If it's like 4 here, so we can say we can break into 4 instances. Okay. So C is breaking into 2 instances. E of n by 2 and E of n by 2. Okay. Then this work becomes a constant work, right? Then we say this like this equation will become this. Yeah. E of n upon 2 we have to put here.
Yeah.
So 2d like n upon 4 plus c. Okay. So for this equation, this is a total amount of work, like constant, right? So I will write this C equal to C here, okay? Because this is a total work done. So this is a total work done, constant work done. So I will put here and then it's like En by 2, okay? I'm doing step by step, okay? So another one, the same thing we have to do this, right? C, we have constant work, then we have a constant work, so we will write this for E of n equal to same equation, E upon n upon 4. So this is like this is a total work, so this is, and this work is divided into 2 instances, so we will go here and we have to divide, then we have to divide this into T n by 4, T n by 4, and this is T n by 4, T n by 4. You understand that? Any questions? then this became a constant work. This is like we can call this x value, okay? X value is n by 4. Then put it into this n by 4, that will become n by 8. So this one I will drop it, and I will write it here. C is like Tn by 8, Tn by 8. This is C, Tn by 8, and Tn by 8. And this is C and this is C. So we have Tn by 8 and Tn by 8. And this C is divided here. Tn by 8, Tn by 8. Okay. So it will goes down to T of 1. That means work is over. Like T of 1, T of 1, T of 1. So it is T of 1, T of 1, T of 1, T of 1. Then we have to find the time complexity, right? Then add the levels C, okay? This is 2C, right? This is 4C.
Yeah.
You have to look the pattern, okay? This is E, like this is like 1, 2, 4. So what will be this?
8.
Yeah, 8. 8C. And what will be the last one? Yeah? Yeah, NC, correct. NC. Okay? It's simple. If you think it's simple. So this question will come like for 10 marks. So right now you got like 5 marks. And then you have to solve this. N plus C, 2C, 4C, 8C goes to NC. Okay? We have to come out from, we have to take the common C, 1 plus 2, 4, 8, and it is goes to N. Okay? So then, like, if we want to solve easy, so we can like, we can say that n equal to 2k for easy, right? So n equal to 2k. So I am putting here 1 plus 2 plus 4 plus 8 plus is equal to 2k. So as like this is a geometric progression, right? So just get this into the formula and you will find like C is out. You will find this 1, 2a plus 1 minus 1, and 2 minus 1. This is the GM. You can solve it because professor had like given you a lecture on GM, right? Solve it and this will comes out C equal to 2k plus 1 minus 1. So we have to taken this, right? N equal to 2k. So we can 2k minus 1. So here it is C, 2 of n minus 1. So it's we go off, and because like we are taking the upper bound, right? I don't care about the constants. Right? So this is
Is that last one 2 to the n or 2 times n?
this one?
The one right below,
Yes, this times 2 times n.
2 times n?
Oh, my writing is so bad. This is my first, like, this is my third time writing on the board, like, we have this much right, so it's going to be bad. Yeah,
That should be big O or third.
it's big, oh,
Big O.
yeah,
But that should be, it's because total is 2 times 2 over 2k power k minus 1. So that should be 2 times n minus 1.
2 times
Yeah, because the 2k,
2k plus 1, right?
yeah.
So that,
So it can equal to the 2 times n minus 1, right?
yeah, minus
So
1.
that's line.
This one?
Yeah,
Yeah,
so if
2
that should
n
be,
minus 1.
yeah, if that should be third of n.
Big O of n, right?
I think that should be third.
Theta?
Yeah, third.
Yeah, theta is like a closed bound, right?
Oh,
Big O is like a upper bound.
that should be the up. Okay, okay.
Because you had not taken the constant, like you don't know the constant value, right?
Oh, yeah, with
So-
the constant value.
So you can't say that this is like a closest bound to the theta. So theta is closest bound.
Okay.
This much I have to cover for this lecture. The next lecture, Professor Dicta will take. If you have any doubts from this, you can ask Professor Dicta or me in my office hours.